Okay, this is passage number 7. This is question number 37. So we have here that UCP1 most likely reduces the activity of which enzyme? So let's go back to the passage here. Let's see what UCP1 is. It's the uncoupling protein 1. Oh, I should emphasize here I lost my tablet, so my drawing is going to be a little bit rough for this passage, but should get better by the next passage. Anyways, so it is an uncoupling protein 1. And if we read further into this paragraph, we have here that UCP1 directly reduces the proton gradient driving oxidative phosphorylation. So as soon as you hear, the key to this problem here is as soon as you read certain phrases, there should be um, certain bells going off in your head right now. So when I see oxidative phosphorylation, what does that mean for me? What terms do I think of? I think of ATP, for example. And it says here the proton gradient driving oxidative phosphorylation. What does that tell me? It's the part of making energy that drives the protons down its concentration gradient, and that goes through ATP synthase and creates ATP for us. So if we look at UCP, it says it directly reduces this proton gradient. Let's take a look at the diagram here. So what we have are these protons, and it's going to go down this concentration gradient across the membrane and the mitochondria, the inner mitochondrial membrane. And this orange protein here, this is going to be the ATP synthase. So remember, in this part of oxidative phosphorylation, or it's called oxidative phosphorylation because what's happening here is the protons are coming down. This entire protein, it actually moves around kind of like a motor. And as it moves, it phosphorylates ADP into ATP, and this is how our body makes ATP, or at least one of the ways it does. So if UCP, what it's doing is it's going to reduce this gradient. What does that mean? If it's reducing this gradient, you're going to have less. It could be that you have less protons up here. Maybe you have more protons down here. But regardless, that means there's going to be less of a driving force for these protons to go through this protein. And if there's less protons going through this protein, that means there's going to be less rotating of the protein, and less rotating means less ATP. And like I said right here, it says UCP directly reduces the proton gradient driving oxidative phosphorylation. So that means the activity, of the protein activity that's probably going to be diminished the most if we don't have as many protons going through, that's going to be the ATP synthase, this orange protein right here. As for pyruvate kinase, that's a step of glycolysis that doesn't really relate to oxidative phosphorylation or the proton gradient. Specifically, the proton gradient really doesn't exist in glycolysis. It's only for that last step of energy production. In terms of the sodium potassium ATPase, this is when you use ATP to create a sodium and different concentrations of sodium and potassium across a certain membrane. We're not getting anything that here. Remember, we're looking at a proton gradient. There's nothing relevant about this. And a succinyl-CoA synthetase, this is a part of the Krebs cycle. Again, has nothing to do with that proton gradient, with that ATP or the oxidative phosphorylation aspect of this problem, which means, again, UCP is probably not going to be affecting this protein either. So the enzyme that's going to be most affected is going to be ATP synthase due to this explanation. Again, because the protons are not coming down as much through this protein, that means the activity of this protein is going to decrease in the mitochondria. So that means the correct answer is A. So the next question, this is question number 38. It says the information in the passage best supports which hypothesis? So let's take a look at A. It says exercise prevents glucose uptake. And again, because my tablet is really non-existent right now, I'm going to try to do this through verbal explanation. I'm hoping that's still helpful. So again, exercise prevents glucose uptake. Well, let's take a look at what exercise does. It increases UCP1 mRNA levels, expression levels. It increases FNDC5 mRNA levels, increases blood irisin levels, and decreases adiponectin mRNA levels. Well, where does glucose come into play? So it might be difficult for someone to see, hey, where does glucose come into this? But let's take a look at where glucose might be introduced in this passage. And you'll have to scroll down here, and it's right here. So blood glucose levels over time. And you'll see that compared to this control protein, when you overexpress FNDC5 in these obese mice, you actually get lower levels of blood glucose. What does that mean? Higher levels of FNDC5 means higher levels of glucose reuptake. So the cells are taking in glucose. Because why? Because we have lower levels of blood glucose, which means the glucose is being taken in by the cells. And that means FNDC5, higher FNDC5 means higher levels of glucose uptake. Well, what does that mean for us? Well, remember, when we have an exercise, we see higher levels of FNDC5, right? So what that means is exercise, higher amounts of exercise leads to higher amounts of FNDC5, and higher levels of FNDC5 increases higher levels or increases the glucose uptake by cells. So what does that mean? Ultimately, exercise then promotes glucose uptake, not prevents, making A incorrect. There we go. And I'm going to take a look at B here. Exercise promotes less effective cellular respiration. So what does that mean? Remember, cellular respiration is how we're able to take in certain macromolecules and use that to make energy for us. Well, what is inhibiting this? We have UCP1. Remember, it reduces the proton gradient, driving oxidative phosphorylation. So that means even though our body might want to make a certain amount of ATP normally, because of this UCP1 protein, which is exercise-induced, what we're going to see is actually less effective amounts or less amounts of ATP being made. Essentially, we're making less ATP than our body would normally want to. So what does that mean? If exercise leads to higher levels of UCP1, and we know that UCP1 is correlated with or directly causes less effective ATP synthesis, that means exercise then promotes less effective cellular respiration, because remember, cellular respiration is ATP synthesis. That's the final goal of cellular respiration for us. So here we go. Exercise promotes less effective cellular respiration. This looks correct so far. I'm going to circle that, but let's always check the other answers. Exocrine secretions of skeletal muscle act on adipose tissue. What is this talking about here? It's probably talking about the blood levels of irisin. I'm not entirely sure how to pronounce that. It's a soluble protein formed by cleaving the extracellular domain of FNDC5. And remember, this extracellular domain, this is found in skeletal muscle cells' plasma membranes. But the problem here is its blood levels of irisin, which tells us that this is actually a soluble protein that is an endocrine protein. It's an endocrine hormone as opposed to exocrine. So that means that C is probably not correct. And D, endocrine secretions of adipose tissue act on skeletal muscle. Unfortunately, we don't have anything about, the only endocrine that we know here is this irisin. And the irisin is actually going to be made by the skeletal muscles. Remember, it's the cleaving of the extracellular domain of FNDC5. FNDC5 is found in skeletal muscles, which means the irisin, which is the hormone, the endocrine that we're looking for here, the endocrine system that we're answering this question with, that's going to be from the skeletal muscle, not from the adipose tissue. So it's not going to be D. Remember, it's the endocrine secretions of the skeletal muscle. That would be what this irisin, that would be something that's correctly describing irisin, which is why D is wrong, because it says adipose tissue instead of skeletal muscle. That leaves us with B as the correct answer. All right, this is problem number 39. This is question 39 of the passage. It says here that the mice that overexpress PGC1 alpha, specifically in their skeletal muscles, are most likely to exhibit which phenotype relative to wild type mice? So let's take a look. So what happens? Mice with skeletal muscle PGC1 alpha overexpression, even without exercise, what do we see? Compared to no wild type mice without any exercise, if we compare these two groups in orange here, right? We see that even without exercise, if you overexpress the skeletal muscle, we're going to have higher levels of UCP1, higher levels of FNDC5, not determined, nothing about the blood irisin, and then lower levels of adiponectin mRNA. So what does that mean? It kind of looks like even if you don't exercise, if you overexpress PGC1- or PGC-1 alpha, you're getting these expression levels that are pretty similar, or these patterns that are similar to what you would get with wild type mice if they exercised, right? So even though, I mean, and this is 2.5 and this is 25, so of course this is wildly different values. What you see is that compared to wild type no endurance exercise, you get an increase in both of these green cases here, right? So that's just something to keep in mind right now. So let's take a look. Number one says lower body weight. So lower body weight. So what does that mean? Well, what can we think about lower body weight? Well, what we have here is that with UCP1 mRNA levels, they increase when you have this skeletal muscle with PGC1 alpha overexpression compared to just wild type mice. So we're going to go back to these two orange groups that we're comparing right now. we have higher levels of UCP1. What does UCP1 do? Remember, this is something that directly reduces the proton gradient, driving oxidative phosphorylation. And so I guess this is a little bit key information that you need to know here. When you uncouple the proton gradient from oxidative phosphorylation, what does that mean? So instead of the protons coming down and directly using that energy to create ATP, that energy is just dissipated off as heat. That's why this is something called that's uncoupling, since it's inefficient, for example. You're just creating heat as opposed to energy that our body can use. Another clue here is that the number of calories used during physical exercise is greater than the number of calories used for the movements themselves. And remember, and the second sentence here says that the UCP1 might be one of the reasons for this. So what does that mean? If you have higher levels of UCP1, you're going to burn more calories. You burn more calories, what do? You get lower body weight. So A looks like a pretty attractive answer right now, but let's take a look at B, C, and D. Let's look at B, lower body temperature. So like I just said, remember, when you're uncoupling something from oxidative phosphorylation, instead of seeing higher levels of ATP and you dissipate that off as heat. So if you're dissipating heat, remember, PGC-1 alpha increases UCP1 levels compared to wild type without exercise. So the two orange groups we're comparing again. And if you're increasing UCP1 levels, you're creating more uncoupling, and more uncoupling means more heat. So you'll actually be seeing higher body temperatures, not lower. C says higher physical activity. Physical activity is not really determined by anything here. PGC-1 alpha, not really determined by that. Not really determined by UCP1, FNDC5. Physical exercise is actually something that works upstream, so it's not affected by PGC-1 alpha or by UCP1 or anything like that. It's working upstream of these different proteins. So what that means is, remember, exercise induces UCP1 expression, not the other way around. So we're probably not going to see any change with the physical activity of these mice. We're just going to see different levels that are downstream of PGC-1 alpha or downstream of physical activity. Since remember, physical activity is upstream of PGC-1 alpha or UCP1. Yeah. Yeah. That's something I was looking for, is just this sentence right here. Remember, PGC-1 or -1 alpha induced by exercise. So just keep that in mind again. Physical exercise is upstream of PGC-1 alpha and upstream of UCP1, which means it cannot be, it's probably not going to be affected by these downstream components unless the passage directly says so. Finally, D says higher non-fasting blood glucose levels. Let's go back to where glucose is shown. Remember, glucose is determined by FNDC5 for this passage. If you have FNDC5 overexpression, you see lower levels of blood glucose. So if you have PGC-1 alpha overexpression compared to wild-type mice, you have far higher levels of FNDC5 expression. Look at 80 versus 1, so 80 times the amount of mRNA levels, at least by this table. I don't know if the numbers are actually scaled that manner, but 80 to 1, that's a huge difference, at least by the table's standards. And remember, higher levels of FNDC5, lower levels of blood glucose. So PGC-1 alpha, what does that do? It increases FNDC5 levels, which in turn decreases blood glucose levels, so you'll probably be seeing lower levels of non-fasting blood glucose, not higher, which makes A the correct answer for us. This is question 40. This is the last question of the passage. It says here, the viruses that encode either FNDC5 or control protein transfer genetic material via blank. This is basically a discrete question. What we have here is, remember, it looks like here we go. The viruses, they inject viruses that encode either FNDC5 or control protein into obese mice. So what they're doing is they have these viruses that contain certain nucleic acid material, this DNA, that will essentially carry this FNDC5 or control protein expression and then inject that into these mice. And we're hoping that these viruses that carry that will then deliver these constructs into these cells of the mice. So then what is that process called? Well, if you just know right off the top of your head, this is actually called transduction. This is basically textbook definition of what's happening. Using a virus as a vehicle to then deliver certain genetic material into the cells. Specifically, we have eukaryotic cells here since we're looking at obese mice. But it doesn't matter. Regardless, this is transduction since you're using virus. I mean, you're using a virus to deliver genetic material. That should immediately tell you that, oh, great, this is transduction since we're using viruses to deliver something. A, what is transformation? This is when you have prokaryotic cells like bacteria, and then they just take in the DNA that's around in their surrounding. So if you just think of bacteria just swimming in an ocean of some kind of solution, and there's like these molecules of DNA. We're hoping that, let's say this is the bacteria in blue, and we're hoping that the bacteria will absorb or take on some of this DNA, hopefully. That's what transformation is. Of course, it's a little bit more complicated than that. There's some manipulation that you can do for this, but for the sake of this question, we're just going to leave it at that. What is contamination? Contamination is exactly what it sounds like. It's just when you contaminate something. So, for example, getting your lab equipment dirty. That's contamination. There's nothing special about this for us here. Now, what is conjugation? This is when you have two different bacteria, and this is when they exchange nucleic material with each other. So what we know here is we're using viruses, first of all, and we don't have any bacteria, at least for this part of the question, or this problem, or this passage. Since we're looking just at viruses and not looking at bacteria that are exchanging material with each other, we know it can't be conjugation, which means B has to be the correct answer for this problem.